Welcome back. In this lesson, I want us to create a server and set up for our handler or handlers. Okay, so in main, we're gonna set up a few things. So let's get rid of this. Okay, and the first thing that I want to do is to actually specify a constant variable that will keep our version number for our application. So for our application, and I'm sure you're familiar with development, whereby you have different versions of the software, version 1, version 1.2, etc., etc. Okay, so let's do that. So we have the application version number, and we're going to see that's a const, and it's going to have the version number as a string 1.0.0. Okay. Okay, so we want to have the option for configuring our server similar to what we did in the previous series in creating web applications using Go. Okay, so I'm going to create a struct. All right, so config, and this struct will contain two fields. One will be the port with type int, of course, and the other field will be env, short for environment, which will be a string. And by environment, I mean whether the environment is you're using a development server, development environment, or maybe a staging environment. Maybe it's a production environment, okay, the real thing, that sort of thing, okay. So that is what we mean by environment. Okay, so let's talk about dependency injection. By now you are familiar with the idea of dependency injection. So we're going to keep that same idea. Whatever our handlers need, we will place them in a struct named application, and so that way it will be available to our handlers. Okay. So again, I'm going to create a type named application. And whatever the handlers need, I will place in here. So initially, we're going to have a field name config, which is of type config, which we just created. Okay. So this field is a struct. Okay. So this field contains a port and an environment variable. And of course, let's create a logger. And of course, we know logger is of type log.logger. Okay. Okay, so that is our dependency injection taken care of. And let's actually jump into main. So let's create a variable of type config. Okay. All right. So again, CFG is of type config, so it will have a port and an env attached to it. Let's go ahead and create a logger since we're going to need one to report messages concerning the server. So let's just say log.new. Of course, later on, we're going to centralize error handling and reporting like we did in the previous series. So os.std out. Okay. And oh, hold on. I think I'm going ahead of myself. Let's get rid of this. Let me back up. Okay. I need to read in the flags that are needed to populate the our config. Okay, so we will allow the user to specify the port and the environment. And again, we're going to use flags to do that, which of course you already know. All right. Oh, shouldn't be here. All right. Okay. Okay. So our first flag, okay, will of course be responsible for accepting the port number, okay, in var, and it specifies that we need to provide 4 things. The place where we're gonna save it, okay, so it's a pointer, of course, so we want to put that in cfg dot port. Okay. And then we must specify a string name. Okay, so the user will use the name port. Okay, and then of course we need to specify a initial or a default value. So let's use 4000. And then of course we need a usage string, which can be something like API server port. Okay. Now, in the previous series, we didn't use inv. We simply used int, and that was because those variables or those flags are being stored in variables. But because we're storing our flags in a struct, then that's why we need the int var. Okay. All right. So that's something that you need to be mindful of. We're storing our values inside a struct, so we don't use int, we use int var. Likewise, we will use string, okay, string var. All right. And so again, I need to provide where that will be stored. So cfg.env. I need to also specify the name that we will use for this flag, env, default value, which will be development, and of course we need a usage string. And so we will tell the user that if they don't know, it's environment. Okay, and environment can be development, or it can be staging, or it can be production. Okay. All right. And so those are the 2 flags we need. Of course, once we have our flags listed, we will simply say flag that parse. Okay, this step is very important. If you don't do this step, then we won't get access to our flags. Okay, let's move on. Let's create a logger. Okay, so logger is log.new. Again, we've done this previously. So os.stdout. Okay. In other words, a command line. Okay, so I'm gonna keep this. Okay, let me show you. All right, it asks for, do you want to put any prefix? No, we're not gonna prefix anything yet. Okay, we're not gonna use info. We're not gonna use error. Okay, for now, we're gonna have no prefix. So log.ldate. Okay, and we also want log.ltime. Okay, that's it for our flags. And so now we can actually create an instance of our application struct. Okay, so remember we're using the application struct for dependency injection. Okay, let's see here. Okay. Okay. So again, I will give it the name app, and I will simply say I want to create a new instance of the application struct. And so I don't have to say new, I can just use ampersand. Okay, so ampersand application simply means I want to create an instance of the application struct. Okay, and so config will be initialized with the CFG variable, and the env field, okay, env field will be initialized with the, oh, okay, take that back. It's logger. The logger field will be initialized with logger. Okay. All right. We have that completed. Let's move on. And let's actually create our server. So let's create our server. Okay. Or you could see our new serve mux. Okay. So again, we're going to use the new serve mux function, and later on, of course, we will use a third-party router. But for now, serve mux can do the job. Okay, so mux is going to be http dot new serve mux. Okay, great. So we will simply use mux. Okay, so mux.handle func. All right, and of course we need a URL, and that URL will be v1/health check. Okay, and we obviously need a handler. Okay, handler function, and we will simply call that handler function health check handler. Okay, again, notice we're prefixing the handler name with the app name because we will perform dependency injection. All right, so obviously we need to create this handler function. We'll do that in the next lesson. And so let's simply create our HTTP server. Okay, and we will simply configure our server. Okay, so again, we're going to create an instance of our server by using the ampersand. So http dot server. Okay, and of course there are a few things that we can add. Address, which should be a string. So we could hard code the string, or we could simply provide the string using sprintf. Okay, so let's create a formatted string. Okay, and so we can simply say colon modulus d. Okay, and so that gives us the ability to actually specify the port number from our config type. Okay, so cfg dot port. Okay. Okay. All right. So let's get rid of this. Get that there. Okay. Good. So whatever port the user passes in, its address will still be correct. Okay. So no need to hard code the string. Our handler, of course, will be mux for now. Later on, we'll change that. We can add things like idle timeout, which we talked about previously. Okay, so we could say time that minute. Okay. We could add read timeout. Okay, again, these are things we talked about. And of course, we could do things like write timeout. Okay. Okay, and that's okay for now. Okay, so obviously we can now start our server. So start our server. Okay, and of course, we will use the logger variable that we created. So logger.printf. Okay, and then we could say something like starting, okay, modulus s server. Modulus s will be our env variable. Okay. On modulus s. Okay, and we will fill these placeholders with cfg that env, and the port will come from srv that addr. Okay, so notice I didn't get the port from cfg that port. Okay, I got it from svr. Okay, I got it from here. Okay, so if our server returns an error, of course it means the server has stopped. Okay, so we don't expect the server to stop under normal circumstances. So anyway, we will call the listen on serve function, and if there is a problem, an error will be returned. And so if an error is returned, we will simply log that error. Okay. Okay. Again, this is really nothing new. All right. All of this should be familiar to you if you have completed the introductory course on creating a web application with Go. All right, so code looks okay. I will not commit it as yet. I will not make a commit. So I will leave this video here. I'll stop here. And in the next video, we will simply go ahead and we will implement our health check handler. Okay, I'll see you in that next video.